Hello, today we're going to be taking a look at a type of math called linear programming. So a tool that's used quite often and extensively in the business world. So today you're going to need your notes, and I ask that you are making sure that you're listening with your audio today because I'm going to do quite a bit of explaining and you don't need to copy everything into your notes. So be paying close attention to where that little pencil is. First, we'll start with what is linear programming. This is marked with a little pencil, so please make sure that you write this part down. Linear programming is a mathematical tool for maximizing or minimizing a quantity, usually profit or cost of production, and it's subject to certain constraints or limitations or restrictions. So it's this idea that lots and lots of business decisions involve companies coming together and deciding what to produce in order to make the most money or what to produce in order to minimize their cost. So a lot of these decisions are made by business management and they involve linear programming. So this is the type of math tool that they use. This tool was developed sometime around the World War II era, and so relatively, it's pretty new, relatively speaking, in the world of math. It's relatively new. And like I said, it's used quite extensively in the business world, economics, manufacturing, production, planning, business management. All of those things involve understanding that business decisions are made with profit in mind, but you have limitations on the amount of things you can produce based on your supply. So I want to take a look at just one sort of problem like this. Tomorrow when you come to class, you're going to do one with me, but today you don't need to write this one down. Just kind of watch and see what happens. So let's kind of set the stage. There's this potter, and he wants to make and sell serving bowls and plates. He knows that in order to make a bowl, he's going to use 5 pounds of clay. In order to make one of those plates, he uses 4 pounds. And the potter has 40 pounds of clay to work with today. And he knows that he needs to make at least 4 bowls. Those are some of his biggest sellers. So if we were to think about what's going on in this situation, a potter is going to make a decision about how many things to produce, how many bowls and how many plates. And he has limitations. He doesn't have an unending supply of clay. And he needs to make at least 4 bowls to restock his shelves. So with that in mind, he can't just decide to do whatever. He's got to take those factors into consideration. These things are called constraints. So if X is our bowls and Y is the plates, we can turn these things, these statements, into inequalities. Like 5x plus 4y less than or equal to 40 is talking about the number of pounds of clay that he has available and how much clay it takes to make each one. X is greater than or equal to 4 says he wants to make at least 4 bowls because X represents our bowls. And Y has to be greater than or equal to 0 because you can't make negative plates. So with these constraints, these are all inequalities. And what we do with inequalities like this when we have a system is we look to shade them on a graph. So we will take these constraints and shade them in a graph to find what's called a feasible region. So using the constraint equation, this is what we'll be doing. We'll take a look and we'll graph and we'll shade, and we'll graph and we'll shade, and we'll graph and we'll shade, and we'll decide where the shading overlaps. The shading overlaps in this situation in that little gray triangle right there. That means any point in there, the potter has enough clay to use and he would be able to fulfill his constraints, his limitations. He would be able to work with that anywhere inside that gray region. But, that feasible region, while it's the region which consists of all the possible solutions, he can choose from any single one of those and be okay. The potter has a business to run here. He doesn't just want to be okay. He wants to make money. In fact, he wants to try to maximize his profit. So the big question really is, how can the potter be sure that he's maximizing his profit? Any point in this gray region would be fine, but he wants to choose the ones that would make him the most money. So what if the profit on a clay bowl is $35 and the profit on a clay plate is $30? Well, then he would set up a profit formula. Profit equals 35x plus 30y. And he would use that to test some points in here, in that gray region. He would use that to test some points in there to see which ones make him the most money. Now, there's a lot of points inside that gray region. So we don't want to be testing every single one of these. we're going to use what's called the corner point principle. The corner point principle says that in a linear programming problem, the maximum value for profit, or in some cases the minimum value for cost, will always be found on a corner point. So that means I don't have to test every single one of those. I'm going to focus my attention on these corner points. Little smiley faces popping up here. Those are where my final answer is going to come from. One of those three in this case. So either 4, 0, 8, 0, or 4, 5. Now knowing that that's where my solution is going to come from, that's not a lot of points to test. It's better than testing every single one inside that gray region. So using the corner point principle, we'll go ahead and plug in all of those corner points into the profit formula to see what kind of profit they would make this potter. So if I plug in the 0.40, I end up with $140 profit. Not bad. 80, $280 profit. That's twice as much. 4.5, I actually end up with $290 profit. So it's best for the potter to create 4 clay bowls and 5 clay plates, and he would be maximizing his profit then if he sold them all. So knowing that, we would then say that is the final solution for this linear programming problem. So I'd like you to take a minute, we're almost done here, copy down these steps. These are the steps we just kind of went through. First we read the problem, then we set up the inequality constraints. Those are the limitations, or those are the factors we have to consider. Then we would want to write a profit or cost formula to be considered later. We need to graph inequalities to find our feasible region. And then we know we're going to use the corner point principle to find the maximum or a minimum in some cases. So these are the steps that we're going to go through tomorrow as we solve our linear programming problem. Okay, thank you very much, and I will see you tomorrow.